using 5-digit number and getting a 3-digit house number. I can look at this as if this is 5 students, and I want to put them in a row. Okay, so I want to arrange 5 students in a row, but I only have 3 chairs. So how many ways in which can I put 5 students into 3 chairs? All right. So again, my decisions are the blanks. That's how many decisions I have to make. So in the blanks, I place in the value of the number of choices that I have. So in the first one, how many choices do I have? 5, right? 4, and 3. And so therefore, there's 60 ways in which we can do that, correct? Okay. Now, a permutation. Now you got it. Permutations and combinations. It's not so significant in this class as much as it is in pre-calc, because the questions get worded in such a way you have to determine whether it's a permutation or a combination. So the very first thing that you have to do is understand what a permutation is. A permutation is where you select and order the values. So that's essentially what I did. I picked 3 students there, and then I had to arrange them in order. This right here is super significant to you. Order. You have to remember that if there is a suggestion of order, you're using a permutation. So for example, if I took this class here and I said I wanted to select a president, a vice president, and a treasurer, I am very specific as to the order. So that's a permutation. Now if I said I need to select 3 people to go out in the hallway, and I don't have to put them in any significant order, that's what we refer to as a combination. Okay? Now why are these so important? Well, I'm going to show you how this works. And this is my favorite example to use. So first of all, a permutation, again, is what NPR is. Now you have this on your calculator. What this does is this takes the amount that you're going to choose from and then order them after you have selected them. All right, so for example, in our question, just before I do that, this is what NPR means. I take n factorial and I divide it by n minus r factorial. Okay? Now I'll explain all of this with your calculator in a second. But here's what happens. 5p3. Okay? So that's what I've got here. 5p3. I've got 5 people and I want to select and order them 3 ways. So my n value is 5 factorial. My r value is 3. So what do I have? 5 factorial over 2 factorial. And if I expand this, I've got 5, 4, 3, 2, and 1, right? Over 2 times 1. And when I cancel, what am I left with? 5 times 4 times 3. Which is that right there. This is what we refer to as a permutation. This method is called the fundamental counting principle. This method is used as a permutation. So we are going to look at a permutation and we're going to look at a combination. Okay? For today, our focus is on a permutation, in which order is important. Now, on your calculator, take your calculator out right now, please. On your calculator, you're going to put in 5. So everybody clear your screen, put in 5, go to math, go across to the probability part, and find NPR in there. What number is it? 2. 2. Hit that. then hit 3, then equals 60. Okay. All right. So yesterday and today, our focus was on how do we arrange things in a specific order. Okay. If I want to test you guys here and want to find out the first, the second, and third place, that's an order. All right. So I would take 20 and find out how many ways I can arrange in order first, second, and third. I go 20p3. Okay. Now, the difference between a permutation and a combination can be used by showing the Lotto 649. I mentioned this yesterday. The Lotto 649, in order to win it, you have to select 6 numbers from 49 and get them all right in order to win it, right? Well, that's a combination. So all you need to do is, out of those 49 numbers, you need to select 6 of them. So let's find out, what are the odds of winning the Lotto 649? So put this into your calculator. 49. Go over to the math again and find NCR this time.
Why NCR this time?
Because I'm only selecting them. I'll explain in a second, Sam. It'll make more sense right away. What do we get? 14 million something? Or 13 million something? 13 what?
13,983,816.
So in order for you to win the Lotto 649, you have to select 6 numbers from 49, right? You have a 1 in 13,983,816 chance of doing that, of selecting the correct 6 numbers. Now, what happens, and there's in the States they have what they call a Powerball. And the Powerball works very similar. I'm not sure the amount of numbers, but you got to select the 3. Those 3 numbers have to be in order that they're selected in order to win it. So you have to select less. Well, what happened if I said to you, all right, you have to not only select the correct 6 numbers, but they have to be in the correct order. What are the chances of you winning the Lotto 649 then? So that's now a permutation. What is it? 1 times 10 to the 10. Right? So you have a 1 in 10 billion chance. Or sorry, 1 in a 1 billion chance of winning the Lotto 649 if they said that you had to get the right 6 numbers and, excuse me, in the exact order of them. Does everybody understand the difference between permutation and combination?
Yeah.
In combination, you just have to pick. In a permutation, you have to pick and put them in correct order. Order is important. All right? One thing we didn't talk about yesterday, because it just comes up today, is 0 factorial. What is the value of 0 factorial? 0 factorial is 1. Okay? Does everybody understand that? 0 factorial is 1. All right? I'll eventually explain as to why, but for right now, I just need you to remember it. Okay? All right, let's look at the first example for this. How many different permutations are there of 5 objects from a set of 7 different objects if repetition is not allowed? Okay, we're going to use, just a second, we're going to use the fundamental counting principle to do this question. So how many decisions do I have to make?
7.
How many different permutations are there of 5 objects, of 5, from a set of 7? So how many decisions do you have to make? 5, right? 1, 2, 3, 4, 5. How many choices do I have for the first one? 7. If repetition was allowed, how many choices would I have for this one? 7. And then this one? And then this one? Right? So if you were allowed repetition of numbers, that's the way it'd be. But because I'm not, it works like this. 6, 5, 4, and 3, correct? Right? If you can't, you're not allowed to repeat numbers. You got to take one out each time. All right? So using my permutation then, I have this, 7p5. So you could use your calculator, or you could break it down using the equation. 7 factorial over 7 minus 5 factorial, which is 7 factorial over 2 factorial, right? Which would then leave me with 7 by 6 by 5 by 4 by 3. Okay? Or you could punch it into your calculator, 7p5, and get your solution. Pretty easy so far?
So if it were repetition, you would use the C one.
No. No. If it was repetition, the correct answer to this is 7 to the power of 5. I have a choice of 7, I have another choice of 7, another choice of 7, 7, and 7. So if you were allowed to repeat digits, you'd have that many ways in which you'd select it. It no longer becomes a permutation. Okay? All right. Example 2. There's 3 examples in this. Example 2. Marta is writing a science fiction story in which the serial number of a starship can have 1, 2, or 3 different letters, followed always by 4 different numerals. How many different starship serial numbers are possible? Okay. So what's the one thing that I have to look at in this question? What's the one thing that I need to pay attention to? Is there just one way in which we can solve this? In terms of my decisions? Sorry? There's an order, so that means that it's a permutation, right? Yeah? Okay? So here's the thing. It says I can have 1, 2, or 3 letters at the start of it. So I need to focus on that aspect of it. That's a restriction to me. So let's do it if I have 1. So I have 1 letter, and then what do I have? 4 different numerals. So 1, 2, 3, and 4, right? Like that. Okay? How many letters do I have to choose from? 26. How many numerals? How many? 10. Because we have to include 0. And do they have to be different? Let's say 4 different numerals or not?
Yeah.
Alright, 4 different numbers.
Okay, so then I've got that, right?
I don't understand how you want to order them.
I'm not putting it in any order, Sam.
So the 26 could go in anywhere?
No. It says Marta is writing a science fiction story in which the serial number of a starship can have 1, 2, or 3 different letters followed by.
How many letters do we have?
Oh.
Okay, now what happens if I have 2 letters? I still have 4 numbers, right? So this is still 10, 9, 8, and 7. Correct? Okay, so 26 here and then 25. And then my third case would be 26, 25, 24, 10, 9, 8, and 7. And what would I do with all 3 cases? Add them. Right? Each time you have a separate case, you add them up. Okay, so far?
So you still times them, but at the end you add all 3 up.
That's right. Multiply going across, add going up and down. Yeah.
And if you pick 26 the first time, why wouldn't it be 25? Because like in each, the the first.
This is
two.
if I have one letter at the start. This is if I have two letters at the start, and this is if I have three letters at the start.
Okay,
Because it
so
says
they're
I can
different
have one,
options.
two, yeah, they're different options.
Okay.
I can have one, two, or three of them, right? Okay? So far, so good? Okay, same as yesterday's work. Didn't change this. All right, let's look at the last question then. A set of 6 numbered symbol cards includes 3 cards with circles, 2 cards with squares, and 1 card with a kite. How many ways are there to lay out the cards in a single row so that the circle cards are 2nd, 4th, and 6th from the left? All right, let's start with the number of choices I have. How many choices do I have? Yeah, no. Okay, you're ahead of yourself by one step. How many choices, or sorry, my bad. I worded it wrong. How many decisions do I have? 6 decisions, right? Okay, so 1, 2, 3, 4, 5, 6. All right, so the 2nd, the 4th, and the 6th have to be what? Circles. So how many choices do I have for the 2nd one? 3, the 4th one? 2, and the 6th one? 1. Okay, so this is circle, 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 right? Right? Okay. So far, so good? So now how many choices do I have here? Here? And here? 1. Okay, so far? 3 times 3? Times 2? Times 2? 36. Again, the work's not difficult, is it? Write out the blanks for your decisions, right? Once you have your decisions made, put the choice number in each blank. Okay? Anybody down to the end of 4.2? Okay. Nice to see you. Let's go.
Yeah.
Quiet. 4, 4, 4, 5. If I do Monday, 4, 4. No, I'm gonna need to do 4, 5, and 4, 6 on Monday because I'm away Tuesday, Wednesday. So let's look at 4, 4. 4, 4 is simple and quick. Okay, so I'm gonna show you this really quickly. Permutations when objects are identical. All right, first things first. How many ways can I arrange the word seen? No, just how many ways can I arrange the letters of the word seen?
24.
How many?
24.
How you get that?
4 times 3 times 2.
Okay, so 1, 2, 3, 4, right? 4, 3, 2, 1 equals 24. Everybody follows that? 4 factorial. Number of letters, right? So you got a choice in each blank. Number of decisions is 4. 4 letters, 3 letters, 2 letters, 1 letter. Everybody's okay with that? Yeah? Okay, now I could write out all those combinations. I'm not going to. There's 24 of them. What about this though? How many ways can I arrange the letters of the word seen? 3, 2, 1.
Or simply one, still 4 letters.
Still 4 letters?
Should be.
Yeah.
It's gonna be the same.
Let's start this. Okay? I'm going to use what you're saying. Okay? Here's word number 1, right? Word number 2. So far, so good, right? Okay? Now I can go, so I can do stuff like that, right? So is that another one?
Yeah, because these can be flipped.
Sorry?
These are still.
Oh, keep going, Jake.
It's the same word, but it's like both of you have E1 and E2.
But I don't. But I don't. That's the point. Okay? So yes, you're absolutely right. If I could E1, E2 it, or E red, E green, whatever, I would. I'd still have 4 factorial. Just like this. But I don't. Okay? So, how many ways can I arrange this then? Any takers? Do you have any idea? How many? 20? Anybody else want to guess? 12? 6? Okay? Alright, here's what actually happens. Take the number of letters. Now, remember, I'm talking about order here, right? So I'm going to divide by the number of ways in which I can order the 2 E's. Because it doesn't matter if it's EE or EE, it's still EE. Do you understand what I'm saying? So E1 and E2 and E2 and E1 without the 2's and the 1's are the same thing, right? So I divide by the like letters. So how many like letters I have? 2 factorial. The correct answer is 12 here. So there's the correct answer. Okay? So far, you guys understand why I'm doing this? Okay, so now I'm going to show you. Now I'm going to take it up a notch here. How many ways can I arrange the word Winnipeg? The letters of the word Winnipeg. Okay, so how many letters are there? 8 letters? So I got 8 factorial, right? Okay, so far? I am now going to divide by, not 4 factorial, no, individual. You have to do it individual. So there's 2 i's, right? 2 factorial, correct? And there's also 2 n's. So I got to divide by that. You should, yeah. Yeah. But what's 2 factorial? 2 times 1, right? Which is? 2. So 2 times 2 is 4. So 8 factorial divided by 4. Use your calculator to do that. 8 factorial divided by 4?
10,080.
Not 4 factorial.
10,080, you said?
You still put a factorial on that. Can you tell me how to do that one?
Sure. 8. Math. Go across.
All
Yep. Find the exclamation mark. Sure. Anybody else have any issues? You think so? Hey, stop here whining over here. I know you are. What's you got here? Okay, so is everybody okay with that? That's like objects. Alright? Now, the only question, I just show, this is easy. Very, very easy, right? Okay? Now, the one thing that they want to do is take a look at the second example. Ricardo jumps into a taxi to travel 8 blocks west and 3 blocks north across town. Assuming there are no one-way streets, how many routes could the taxi driver take? So he needs to go 8 blocks to the west and 3 blocks to the north, and I want to know how many ways he can do that. All right? How many blocks are there total? 11. So this question is designed like this, 11 factorial. How many blocks does he have to go west? 8. And north? 3. So you can go 11 factorial over 8 factorial, 3 factorial. And then next week I'll show you a different way of solving this question, but for right now, that's all I need for today. So you need to get done for sure to the end of 4.2 and beyond 4.3. You'll have all of next week to work on this whole unit, but I'm going to show you 4.5 and 4.6 on Monday. So you'll basically be looking at, by the end of next week, you'll be done all of 4.7. The test won't be next week, it'll be the week after, because there's lots to do in this section. And this is, like I said, this is an important one, because there's a section on terms and comms and pre-calculus that you want to make sure that you know, because we'll go through it very quickly in pre-calc. Now that you're done. Okay, any questions from 4.1 and 4.2 yesterday? Lexi?
3B on number 2.
You what?
Well,
Okay, actually, how did you, I just told you this yesterday.
I only got 4 and you're not 5. And I drew everything out. And
Sure you
did.
Okay, when it comes to the dice, the die, your best case scenario, and you're going to deal with this in probability in pre-calc as well, you want to write out all of the outcomes in this case and just count them. That's the easiest way to do this question. Okay? So it says rolling the sum of an 8 on 2 standard dice. So there's 36 possibilities. So my suggestion to you, and I would tell you, I'll tell you this every single time, I'll tell you in pre-calculus to do the same thing. When it comes to dice, write out all your outcomes. Okay? So we're talking about sums here, right? So Lexi, how did you not get this?
I forgot a row
It's
because
like a
it's just
simple
squishy, so I
multiplication
switched
table.
it once.
Sum table. It's not a multiplication
Well,
table.
it's like the
It's a sum.
same thing though.
Yes.
Like numbers on top, numbers on
Yes.
top.
How many 8s are there? That's the easiest way to do the die question with sums, is actually write out your outcomes for that. Okay? Anybody else have questions from yesterday? No, you can wait and ask after. Everybody else needs to work. Nobody else has questions? No. Okay. Get to work then.
Can I go to the washroom?
You may go to the washroom.
Mr. Reed, I sure got my earphone charged.